Hi everyone, welcome to lesson 1 for semester 2, inheritance. And inheritance is going to mean probably what you would think it means. We are really talking about that moving of wealth forward across family generations. We're going to talk about parents and children, and really inheritance is one of the key pieces that allows us to do object-oriented programming. So we get this ability to create this sort of family tree. You'll have children. Children typically will only have one parent. Java has a few ways around this, but for good, solid programming design, we really only want to have one parent. It's kind of like you would have to cross a bird and a mammal to get a Pegasus, right? Like that's just sort of crazy. That doesn't really work, and we're just going to go on that the platypus ever existed, but we really want to see sort of direct straight lineages when we look from a parent all the way up to its children. So in Java, everything, absolutely everything, is an object, and that's how a lot of our containers work. And this is really, really important. And so when you talk about a parent, it's a superclass. Subclasses or children are the when you're looking at it from the other direction. And realistically, anything written in the parent is going to be available to the child as long as it is public. Protected information means it's like a family secret, and private in a parent will be private from its children. And so when we take a look at a larger scale design, we want to ask ourselves, who's responsible for this piece here that I want to have ultimately at the end of the day? Should it belong to the parent? Should it be framed in the parent and have the child define it later on? And if we do this and we build things back in the parent, we can start doing polymorphism. And polymorphism, the roots are poly and morph, meaning of many forms. So we can use a parent reference or the handle of class A, and it's actually holding class C, which is 2 generations down the road from it. And that's really, really important because typically our containers are only going to hold one thing. Java, again, works around that a little bit because everything is fundamentally the same as when it's created from objects. And so if we have a parent-child relationship, that's an ISA relationship. So C is a B, B is an A, right? So an A reference can work for class Cs. And a has a relationship on this slide means internal data members, like what are the values that it has. So a class can have a class within it, specifically as some sort of data component. So for example, in a student model, you would have addresses. Addresses would also be a class. So that's really a has a relationship because the student is a address, right? And so polymorphism is sort of the extension of inheritance, and you're going to learn about abstract classes as well. And it's what allows us to get richer, more powerful programs. And again, by reducing the amount of code that we write and really duplicate all over the place, we reduce our amounts for failure, and we can achieve more sophisticated results and more targeted results, really. So this is a really big concept. I hope you're ready for it. It's going to be a lot of fun. So thanks, and welcome to semester 2 once again.